Welcome to Inquiry Science, Week 2, Launching Inquiry for Bilingual Learners. During Week 1, we looked at ways to assess bilingual learners' assets in terms of language, process skills, and science content knowledge. During this week's learning, we'll discuss ways to launch the inquiry process and examine student language production during observations. Our guiding questions this week focus on using student observations to launch the inquiry cycle. They include: what should students observe? How should students observe? What type of language should we encourage students to use during observations? And what supports should we give to bilinguals during observations? Let's begin with a quote from Albert Einstein, who claimed that he had no special talents, that he was only passionately curious. While some may argue that Einstein did indeed have some very special gifts, it is at least worth considering what his statement implies for all our learners. The classroom environment and the teacher's choice of activities will certainly have a large impact on whether student curiosity will be fostered or stifled. An inquiry approach allows teachers to encourage students' natural curiosity and leverage this engagement to facilitate deeper learning. What kind of observations will foster passionate curiosity? Direct observations help launch the inquiry process. But that does not mean that teachers need to prepare an elaborate show. Science magic tricks and demonstrations of the kind seen at museums are fun and engaging, but simple, hands-on, direct observation may actually be the better choice for the development of scientific skills and language skills. Simple experiences, such as observing the melting of ice or the mixing of a drop of food coloring in water, can lead students to wrestle with deeply challenging scientific concepts. In any case, having students be active participants and recorders of thoughts and questions is preferable to having students be passive observers. Simple, everyday phenomena, such as the one seen in this video, can foster passionate curiosity. What kind of questions would your students ask when given a chance to observe a small, steady trickle of water running down a sheet of glass or plastic? When students begin to think about the factors that make it meander more or less, then they are on track to begin great scientific investigations. Take a quick look at two very different student experiences. Watch the first 2 or 3 minutes of the following two observations experiences. In the first, you'll see a teacher-centered demonstration. In the second, a student-centered observation. Consider how they differ in terms of building curiosity, but also how they differ in terms of building literacy and language skills. We've considered what students should observe. Now let's consider how students should observe. When teachers ask students to record their thinking with a simple "I notice" and "I wonder" chart, this increases the language demands and the language gains. Next, we'll look at 4 strategies to help bilingual students, especially intermediate bilinguals, during a direct observation experience. We'll look at modeling expert versus novice observer skills, welcoming all languages and all registers, grouping for maximum discussion, and holding off on conventions during the observation phase. Our first strategy is to model expert versus novice observations. Take a moment to think about the difference between observations made by experts and those made by novices. How might your observations of a stream of water trickling down a board differ from those of a more novice scientific observer? Our second strategy is to welcome the use of all languages during direct observation. While standard academic English has become the de facto language of science worldwide, linguists are certain that all languages and dialects are equally capable of describing the world and making meaning. This idea may seem to take away from the importance of teaching academic language. Don't students need precise technical terms to communicate scientific results? When we think of communication between scientific experts, we think of speech and writing done in standard English. With this in mind, we might begin to associate English language skills as prerequisite to the development of complex scientific understanding, but this is not the case. Consider an English-speaking physics teacher working with native Navajo-speaking students. The teacher might assume that a monolingual Navajo, or Diné, speaking students will be at a big disadvantage when it comes to describing the motion of a rocket, because the original pre-Columbian Navajo language lacked technical words like rocket, parachute, and jet. The teacher might decide that students need to learn English first, before trying to describe rockets or study physics. Now consider the opposite situation: a native Navajo-speaking physics teacher working with English-speaking students. The Navajo teacher might assume that monolingual English students will be at a big disadvantage when it comes to describing the motion of a rocket, because English language verbs lack sophistication in terms of describing motion. Navajo verbs convey meaning about the manner in which an object moves, along with classification information about the objects themselves. The teacher might decide that students should learn Navajo first, before they study a rocket launch. In truth, all languages and dialects are equally capable of describing the motion of a rocket. The Navajo language might seem better for describing motion, but with the right modifiers, the English language works just fine. Similarly, English might seem better because we associate technical language with English, but terms and jargon specific to a field are naturally exchanged between languages. Just as English speakers borrowed the terms rocket, parachute, and jet from French speakers, so too can Navajo speakers incorporate these words into native ways of speaking. Because all languages and dialects are equally capable of expressing meaning, making expert, sophisticated observations is a transferable skill. There are some advantages of promoting the use of all languages and dialects at this stage of the inquiry process. By doing so, teachers demonstrate respect for students' home languages and cultures. All observers can struggle to record all their observations and questions quickly, and it makes sense to have a get-it-down philosophy. In the process of working with your multilingual learners through all the phases of inquiry, teachers may be able to use the home language or dialect as a bridge to academic language. This leads us to our third strategy: using group discussion to build language. If all students share their observations and questions in cooperative groups, there is a rich possibility for language gains. Because observations are rich in context, related to the real-world experience they just had, language gains are facilitated. Finally, students will benefit from learning to put observation down onto paper quickly, learning to revise these at a later time. Model a get-it-down quickly with important details, philosophy for initial observations, followed by revision for conventions at a later time. In summary, great launch of inquiry doesn't have to involve big demonstrations, just time to observe and inquire. Teachers teach specific observation skills, but explicitly recognize that observations can be recorded in many languages. A get-it-down philosophy is encouraged. We hope you can recognize the important gains your bilingual students begin to make each time you give them opportunities to observe, write, and share during hands-on science investigations. Happy inquiring, and keep on bringing out the passionate curiosity in all of your students.